Let's take a look at the second page of your assignment. And we want to solve this triangle. And we'll round our answers to this whole number. And we're not given any information, well, except notice we've got all the angles of a triangle. We know if we add all the angles up, we're going to get 180 degrees. So let's use that. So we're going to say 180 equals, let's add up our x's. 7 plus 3 is 10. So I get 14x. Then we'll add up our numbers. So we'll say negative 1 plus 1, they cancel, so we get minus 2. So now let's solve for x. We'll add 2 to both sides. So 182 equals 14x. Let's divide both sides by 14. So we take 182 divided by 14, and we get 13. Now that means the measure of angle A is going to be 4 times 13 plus 1. Well, 4 times 13 is 52, so plus 1 gives me 53. And then we'll say the measure of angle B would be 7 times 13 minus 1. Well, 7 times 13 is 91, minus 1 is 90. That's a key one that's going to help us out here. So we know that angle is 90 degrees. I didn't draw that very well. Let me retry that. There we go. And then the measure of angle C, I could take 90 minus 53 and I'll get 37 degrees. That doesn't look very nice. I'm going to rewrite 37. Now I know I got a right triangle. It's not special because the angles are 53 and 37. I can't use SOHCAHTOA because I'd have to know one of these sides. So I'm going to go back and use Pythagorean theorem. So c squared equals a squared plus b squared. In other words, c, on this case, is actually b, isn't it? Because it's the one opposite the 90 degrees. So I'm going to say 3 minus 1 squared equals y plus 5 squared and plus 2y plus 2 squared. Now remember, when you square a binomial, you don't distribute. If I want to, 3 minus 1 times 3 minus 1. So I'll get 9y squared minus 3y minus 3y minus 6y. I don't know why I'm writing it down here. I want to write it over here. So this is 9y squared minus 6y plus 1 equals y squared plus 10y, because I got 5y times 5y, plus 25. And then I'm going to add 4y squared. I think I'm just going to write that below it. Plus 2 times 2 is 4, so plus 8y plus 4. So I get 9y squared minus 6y plus 1 equals 5y squared plus 18y plus 29. Now, since it's a quadratic, I want to move everything to the left side. So I'm going to subtract 5y squared. Excuse me. And I get 4y squared. 18. I'm going to subtract 18y. I'll get negative 24y. I'll minus 29. I'll get minus 28 equals 0. Now notice I can factor a 4 out of everything, so I think I'll do that right away. So 4y squared minus 6y minus 7. I don't really care about the 4 because it doesn't equal 0. I can divide both sides by 4. Run out of room here because I spent some extra real estate at multiplying that. So I get y squared minus 6y minus 7 equals 0. So that's y minus 7 and y plus 1 equals 0. So y equals 7 or y equals negative 1. And the problem with negative 1, notice if I take 3 times negative 1 minus 1, I'll get a negative answer. So although the negative 1 is an answer to my quadratic, it's not an answer to my problem. So now that we know that y is 7, we can go back and replace that and say 7 plus 5 is 12. And then 2 times 7 is 14 plus 2 is 16. And then 3 times 7 minus 1 is 20. And so we know angle A is 53, angle B is 90, and angle C is 37. AB is 12, BC is 16, and AC is 20. So we have solved that problem, finding everything that's missing. On the last question, 34, I'd take that back. It's not the last question. Are the values of sine and cosine for acute angles always less than 1? Well, yes. Because sine of my angle is the opposite over the hypotenuse. And the hypotenuse is always going to be greater than the opposite side because it's the hypotenuse. So I'm always going to get a number less than 1. And I would say the same thing for the cosine of an angle. That's going to be the adjacent over the hypotenuse. And once again, the hypotenuse is the biggest side of my triangle. So I'm always going to get a fraction that's going to be less than 1 for sine and cosine. Now, that's not true for tangent, but it is true for sine and cosine. Now, remember, cosine means the complement sine. So if I want to find the cosine of 50, that's the same as the sine of 40. In other words, on this problem, it's 0.64. It's going to be exactly the same. The cosine of 50 equals the complement's sine. So the complement of 50 is 40. And since I know the sine of 40 is 0.64, the cosine of 50 is 0.64.